Okay, this is 2D Moments, problem 11. Okay, so here's the figure from the problem that you see in the worksheet for the problem. We have the pivot at the line y equals 1. And for this problem, we're saying that if things rotate in this direction, that's positive. So rotating in this direction is positive. Rotating in this direction is negative. All right, now I've drawn in two different thin slices, a red one that is above the pivot, a green one that is below the pivot. Now the reason why I'm doing this is I want to show you that it doesn't really matter where you put your thin slice as long as you attach the right sign to it, positive or negative. Okay, so remember that dA is the area of your slice, dF is the weight, in this case 2.75 pounds per square foot times dA, and dmy is plus or minus, is going to be a plus or minus, then the distance from the pivot, and then dF. Okay, so first let's start with this. Let's say that we decided to draw our thin slice above the pivot. Okay, I'll talk about that plus or minus, whichever one that what it's going to be in a second. And then dF. Okay, so I'm not computing I'm not writing out the final integral yet. First, I'm just showing you that if you choose your slice to be here, this will be the same as if you choose your slice to be there. And it all comes down to this plus or minus. Remember that for whatever reason we chose in this problem, that positive is when things rotate, when the top rotates out of the board and the bottom rotates into the board. Okay. All right, so the distance from the pivot. Okay, so here y sits there. Okay, so if that's where y is, and the distance from the pivot, this distance right here, right? This is the distance from the pivot, is this little bit right here. Okay, that little bit right there is a distance of y take away 1. So y minus 1. Okay. Now, think of everywhere else except for the little red strip as having no mass whatsoever, or barely any mass, right? So if you're barely any mass compared to the mass of the red strip. Now you think about it, if you were to knock the red strip there, right, this thing would rotate, the top would rotate into the board, right, because there's really no mass here. There's no mass anywhere else except for the red strip. So if you were to knock that part, it would above the pivot would rotate into the board, right? But we said that rotating out of the board, right, is positive. So rotating in would be negative, and so this would have to be negative. So I put that in red to indicate that's what happened with my red slice there. Okay, now let me compute this thing with my little green slice there. Okay, so first the distance from the pivot. Okay, now this is a negative number, right? Y is a negative number because he's below below the origin there. There's 0, right? So y is a negative number. So if y is negative, right, then the distance here, think about this distance from here to there. Right, that distance is a distance of y, but y is negative, right? Distance isn't really negative, so negative y is positive, right? So this is the distance minus y. Right? Think of that as like -2, then that distance would be -2, that would be a distance of 2. Right? So how far down are we? We are 1 minus y. Okay, now think about what would happen if there was no other mass really to this plate here except for on the green strip there, and you were to hit this thing, right, then it would rotate in the positive direction, right? That would go, the bottom part would go into the board, the top, so below the pivot would go into the board, so that would be positive. So we have positive there. Okay, now the thing to notice, right, is that, so look here, right, negative y minus 1, that's negative y plus 1 df, which is 1 minus y. So in fact, you get the same thing. If you distribute that negative through, that's 1 minus y. So in fact, you get the same thing no matter where you put the slice, as long as you get the plus or minus correct. Okay? All right. So what we found is that dmy is (1 minus y) df. Okay, so let's save that. Dmy is 1 minus y. We'll save that down here for later. Okay. So now we want to get the area of a slice. In either case, whether we use the one above or the one below the pivot, we get the same thing. Above, we had a negative y minus 1. Negative y minus 1 is 1 minus y, which is what we got there. All right, so let's get dA. So dA is the area of the slice. I'm just going to go with the red one here. So let me get rid of all this other noise. Okay. All right, so now so the width is going to be on my dy. So we got dy, and now we just need, let's see. So the outer, or right minus left. All right, so right now we have y as a function of x, but we need x as a function of y because we're on the, because we're integrating along the y-axis. Okay, so if y is equal to x squared minus 4, y plus 4 equals x squared, plus or minus square root y plus 4 equals x. Okay, so this top part, so this one over here, right, this is the positive one. If you think of moving x into the positive is over here. So here we have x equals root y plus 4. Over here we have, let's see, x equals negative root y plus 4. Okay, so the way I always think of this, I always go back to like, okay, let's say if we were doing something with the x, right, we'd have the top minus the bottom. That would give us the width of our strip, right? If we were doing something if we're just doing, if we're integrated along the x-axis, we'd say, okay, top minus bottom. Okay, now what is top minus bottom when you're integrating along the y? It's the thing that's positive in the positive, or more positive, more to the right than the left. Okay, so the more to the right, we'd have y plus 4 minus more to the left minus like that. You can see that this is y plus 4 plus y plus 4 dy, which is 2 root y plus 4 dy. Got two of these, like combining like terms, we got two of those. Okay, so there's my dA. All right, so then dF is now my weight, 2.75 times 2 root y plus 4 dy. So that's 5.5, what's that, 2.75. That's 2 3/4, right? So let's see, 2 3/4 plus times 2 is 1.5. I don't know. Let's see, 2. Let's do 10. So there's 2, 14, 15, 4, 5, 5.5. Yeah. Okay. All right. And so now we see that dmy, right? My dmy was 1 minus y df. So we have 5.5 root y plus 4 dy. Something like that. And now my overall mass, integral from -4 to 5. Let's put the 5.5 in front.